The overall goal of this microfabrication protocol is to produce plastic microfluidic devices compatible with Fourier transform infrared microspectroscopy in a simple and cost-effective way.
This method can help advance the understanding of cellular biochemistry. It provides a simplified access to infrared microspectroscopy, a label-free, no-damaging imaging technique which can retrieve biochemical maps of live cells. The main advantage of this technique is that it reduces the need for accessing a microfabrication facility, and it uses plastic as the main component for the final devices. Demonstrating the procedure will be Mona Suryana, a research assistant from our laboratory.
To begin this procedure, prepare the silicon primary mold as outlined in the text protocol. Next, mix the PDMS elastomer and the curing agent at a 10:1 ratio. The total amount mixed is such that the resulting PDMS is approximately 1 to 1.5 mm in thickness. After thorough mixing, transfer the mixture to a vacuum jar. Lower the pressure until it is between 1 and 10 millibar. Wait for 15 minutes or until there are no visible bubbles to degas the mixture. Pour the degassed PDMS onto the prepared silicon mold. Transfer the mold to the vacuum jar and lower the pressure for 15 minutes to degas the mixture once again. Then, transfer the mold to a hot plate or oven. Heat the mold at 70 degrees Celsius for 2 hours to